Now, before we move on to the back of our notes, let's check your number 2. You should have a scale factor of 1/4, which is a reduction of that triangle. So you should get the new triangle, which is much smaller, okay? A prime, B prime, C prime. So it should be right there. Now, let's go ahead and move to the back of your notes. And I would like for you to take a minute and look at number 3. You can see that number 3 is not at the origin. So this is the first time we have looked at something where C, okay, is right here, and that is not at the origin. So the point of this problem is for you to realize that the scale factor does not matter. It does not have to be at the origin. The scale factor is still at work. So the first thing that it asks us to do is to find the length of each. So CR is right here, and it is 1. CR prime is double that, so that is 2. Now, it asks us to find CQ, which is a little bit of a problem because CQ is a diagonal line. But that's okay. We can still do distance formula or just a quick Pythagorean theorem right there. So in order to find the length of this diagonal, I've got a distance of 1 and 2. So if I quickly do the Pythagorean theorem, I will have 1 squared plus 2 squared right there. So CQ is going to be the square root of 5. Now, if I do CQ prime, I'm going to have to go from here to here. So that is 2 and then over 4. So this is 2 and 4. Again, I'm going to do a really quick Pythagorean theorem. So I get 2 squared plus 4 squared. So that is the square root of 4 plus 16, which is the square root of 20, which breaks down 4 times 5, which is 2 square root 5. Now, I hope you see what's happening. This is very easy to see. 1, 2. So that's double. Square root 5 to 2 square root 5 now is also easy to see. That's double. Now, the next thing that it asked me to do is CP. So 1, 2, 3. CP prime, 1, 2, 3, 4, 5, 6. Now, everything is holding true. 3 to 6, that's double. So for CS, it is going to be the same distance that CQ was, and C to S prime. So just trust me that that is square root 5 and that that is 2 square root 5. So it says, based on your measurements, what is the scale factor of the dilation? Now, remember that it is image comes first over pre-image. So the image is the green one on my copy. So the image are these numbers. So let's just take this one. 6 to 3. That gives me 2. Hence, everything being doubled. So everything, if I do 2 square root 5 over square root 5, those cancel out. I'm left with 2. So yes, what is the scale factor? The scale factor is 2. Is this an enlargement or a dilation? This is an enlargement because K is greater than 1. Now, moving on to number 4. It says, answer the following questions if the center of dilation is at the origin. Now, again, everything's at the origin, so everything is following just the simple scale factor. Question 4 says, what is the image of point -8, -24 after a dilation of 1/4? So the point -8, 24 is the pre-image. So after the 1/4, we would simply take the -8, divide it by 4, get a -2, and take the -24, divide it by 4, and get a -6. So the image of that point after that dilation would be -2,6. Question 5, what is the image of the point 5,3 after a dilation of 8? So the image, so let's say if that is 0.53, we are going to dilate it by 8. So this is going to be our rule. So our final image would be 8 times 5, which is 40, and 8 times 3, which is 24. So it's just following simple scale factor rules. Now, question 6 is when things can get a little bit hard if you're not paying attention to directions. It says after a dilation, 5, 0 is the image of this. So P would have been 45, 0. Something happened to it, and then P prime is 5, 0. So what happened to that point? Well, if we go from 45 to 5, you can quickly figure out that we divided by 9. So the scale factor is going to be 1/9. Now, the question is saying, what are the coordinates of the image 10, 7 after that same dilation? So now we have 10, 7, and we're going to do the scale factor of 1/9. So we are simply going to take 10, divide it by 9, and we're going to take 7 and divide it by 9. Those do not work out perfect, therefore we just stop. We just leave them as improper fractions, or just like that, because that one's improper, but this one's okay. But there's nothing we can do with that, so we leave it like that. Now, I would like for you to stop this video and answer the following questions in your video module.